General requirements of fire and gas system philosophy. Objective. The fire and gas detection system is provided based on the Project HSE philosophy and fire and gas philosophy documents. The system's primary goal is to monitor all areas handling flammable, toxic, or asphyxiate materials, providing early detection and alerting operating personnel. This includes activation of alarms, initiation of executive actions for emergency shutdown, and depressurization to mitigate risks to personnel, equipment, and the environment. Fire and gas system design philosophy. The fire and gas detection and protection system aims to provide early warning of fire or gas events in plant areas and buildings. It automatically initiates actions like tripping HVAC systems, closing fire dampers, and activating fire protection systems. Independent fire and gas systems are provided for central processing facility process, utilities, oil well clusters, and remote wells. The systems are SIL 3 rated Safety PLCs designed per IEC 61511 and IEC 61508 Part 2, meeting hardware fault tolerance HFT requirements based on safe failure fraction SFF value specified in IEC 61508. The fire and gas system includes hardware and software for powering and interfacing field fire and gas detection and protection devices, monitoring fire and gas alarms from the Central Processing Facility Control Room, implementing executive logic associated with the fire and gas detection philosophy, initiating fire and gas protection devices like deluge valves and extinguishant release valves, activating alarm signals, beacons, and horns, interfacing with PAGA systems, fire alarm control panels, FAP, building fire and gas systems, and other control panels. The system architecture supports a dedicated fire and gas system for central processing facility processes, central processing facility compressors, and central processing facility utilities. For oil well clusters and remote wells, the fire and gas logic is combined with the Instrumented Protective System, IPS, with separate I/O racks as per the fire and gas cause and effect diagram. The fire and gas system must support the following interface functions: interfacing with high-sensitive smoke detection HSSD systems, fire alarm panels, energen control panels, deluge valves, fire water pumps, electrical small power distribution feeders, auxiliary consoles, manual alarm call points, heat detectors, and other fire protection systems. Initiating audible and visual alarms via PAGA systems. Activating shutdown actions via IPS. Providing system status indication and alarms at ICSS operator consoles. Ensuring extensive self-testing, fault monitoring, and diagnostics facilities for continuous and periodic testing purposes. Gas detectors must be smart heart type with 420 milliamps output. The fire and gas systems should communicate over a redundant network with a common PC and printer provided at the control room for SOE and programming functions. Fire zones. Plant facilities are divided into fire zones to manage fire and gas detection and protection. Each fire zone groups equipment by risk level and is physically defined by its limits and hydrocarbon inventory. The primary purpose is to calculate fire water demand and size the fire water network. Fire zones separate risks and limit escalation probability. Each zone should be monitored by at least 2 fire and gas sensors, allowing for complete isolation and depressurization of hydrocarbons within the zone. Fire and gas devices. Fire and gas detectors ensure personnel safety by providing immediate response to emergency situations. The system acquires signals from various devices distributed throughout fire zones, including flame detectors, multispectrum IR type, toxic gas detectors, semiconductor type, hydrocarbon gas detectors, point and open path IR type, CO2 gas detectors, IR type, manual call points, smoke detectors, heat detectors, fusible plug heat detectors, high-sensitivity smoke detection systems, beacons, sounders, linear heat detectors, and deluge valves. Alarm lights, flashing beacons, and audible alarms should be provided in plant areas and buildings. The audible alarms should be routed through the PA system, with redundancy considered in the design. Automatic water spray systems should be activated by the fire and gas system, protecting identified equipment in plant and utility areas. Fire and gas detection and protection inside buildings. Each building and passive-cooled shelter should have a standalone addressable fire alarm control panel, FACP, that acquires local building detectors, beacons, and manual alarm call points. The panel provides confirmed fire detection signals to the main fire and gas system, activating executive actions within the building. Gas detectors at buildings' air intake and airlocks, including ITR buildings, should be hardwired directly to the main fire and gas system, interfacing with HVAC systems. Fire and gas operator access. The main operator interfaces to the fire and gas system are operator workstation at ICSS, auxiliary consoles, a large screen mimic display at the central processing facility control room. A fire and gas system engineering workstation with printer will be provided for SOE and programming functions. This workstation, along with a laptop, should allow online monitoring, configuration, and maintenance access to the fire and gas system program according to security levels. Major functions. The fire and gas system operates independently to detect hydrocarbon, toxic gas leaks, and any type of fire, perform alarm and shutdown logic, automatically initiate shutdowns, open deluge valves, close fire dampers, and trip electrical feeders. Activate emergency depressurization and ESD2 level shutdowns for confirmed fire. Activate flashing beacons, fire and gas alarms via PAGA systems. Record data for sequence of events and generate DCS alarms to alert operators. Provide startup permissives and activate mimic panels. Activate extinguishing systems. Fire and gas executive logics. Fire and gas executive actions for shutdown and alarm are based on the fire and gas philosophy document. The logic initiates alarms upon detecting abnormal conditions, prevents incident escalation, and avoids unnecessary shutdowns due to spurious events. General rules include configuring logics as non-fail-safe and energized to trip. No time lag between causes and effects unless specified. Providing maintenance override for each initiator with a permissive override enable switch. Confirmed detection requires multiple activations of flame, gas, and manual initiation devices as detailed in the fire and gas cause and effect matrices. Access levels. There are 3 access levels. 1 view only allows viewing the application program and input-output status. 2 maintenance for diagnostics and system configuration viewing, prohibiting program or trip setting modifications. 3 engineering allows modification of configuration, input-output trip settings, and application programs. Maintenance override. Maintenance override functions bypass predefined field fire and gas devices for maintenance activities. DCS soft maintenance override switches MOS should be latched with operators alerted after a set duration. Fire and gas activations should be indicated in graphics, and activation push buttons should be pulse type. Alarm functions. Alarm assessment and rationalization should be performed during detailed engineering. The fire and gas system acquires data from field devices, generates normal alarm conditions, and detects first-up alarms. Inputs should be time-stamped independently of the controller scan time, ensuring accurate sequence of events reporting. Obsolescence requirement. The fire and gas system and components should be supported for at least 15 years from commissioning, with spare parts available for 10 years post-obsolescence. Vendors must notify the company in advance of product discontinuation. Availability and reliability. The reliability and availability of the fire and gas system are critical. The system should ensure autonomy of fire and gas operations, minimal effect of single component failures on overall availability, full redundancy on all inputs-outputs, use of proven technology and redundant power supplies, an assumed mean time to repair MTTR of 4 hours and availability greater than 99.999%. Spare philosophy system spares should align with the ICSS specification, ensuring 30% spare space in cabinets and 25% spare cores in multi-core cables. Spares for instruments and wiring should be provided per the project philosophy. Intersystem signals. From to DCS, FGS functions should be independent of DCS, with non-safety signals transferred by soft links and all signals available via the process control network. From to FGS, oil well cluster FGS nodes should connect to central processing facility FGS through a safety network. To IPS, when both FGS and IPS systems have a safety action on a final device, the combined trip signal should be carried by the IPS. FGS panel. Indications and commands on the FGS auxiliary panel in MCR should be driven from FGS access points. This comprehensive overview ensures the fire and gas system's philosophy and design meet the required standards for safety and reliability in industrial settings.